Um, there's a thing called absolute convergence, and sometimes it can be easier to show a series is absolutely convergent than it is to just show its counterpart just without what basically what we're doing is we're taking the absolute values of each term and showing that series convergent. Sometimes it can be easier to do that than, like I said, just to prove it outright convergent, but let me just show you. So the series A sub n is absolutely convergent which is a stronger type of convergent if the series of the absolute values of the A sub n's is convergent. So you can see why the name is given there, because yeah, you're showing the series of the absolute values is convergent. So if that series is convergent, then this series is called absolutely convergent. Said to be absolutely convergent. And usually it only makes sense if you've got the alternating signs, right? That's really kind of where this only makes sense. I mean, yeah, if we've got only positive terms, it doesn't make any difference if I do the absolute values of them. It's not going to change anything. So just think about that. All right, so let's just determine if the series -1 to the n plus 1 over n squared is absolutely convergent. Determine if that's absolutely convergent. All right, well, first thing to do to show absolute convergence is take the series and do just the absolute values of it, which, what's that going to do? It's not going to be alternating. Yeah, it's just going to take all the terms and turn them positive, so it's going to take this part out, isn't it? So that's just going to be 1 over n squared. It's 1 over n squared. Which this is a good example of one that it's a whole lot easier to do this than it is the alternating sign one, because what is that?
P series.
It's P series. P equals 2, right? And what do we know about P series with P equals 2? Convergent? Right. Divergent. P series are convergent if P is greater than 1. So that's greater than 1. This is convergent. So the absolute value series converges. Well, if the absolute value series converges, then what do we know about the series itself? So, -1 to the n plus 1 over n squared is absolutely convergent. And again, like I said, that's kind of a stronger than just saying it's convergent. If you're saying it's absolutely convergent, it means it converges no matter what. Not all convergent series are absolutely convergent. That, like I said, it's a stronger term, but it absolutely converges. All right? So that's that one. All right, now what about this one? Okay, so determine if series -1n over n is absolutely convergent. Okay, so same deal. Let's look at the series, but with absolute value. The absolute value of each term done. Well, again, that just cuts out the alternating sign, so that just makes it 1 over n, and even the absolute value goes away there because I'm talking n equals 1 to infinity. I don't do any negative powers of n. So what is that? That's harmonic. That's the harmonic series. That's divergent. So what does that tell me? Well, that tells me, so negative 1 to the n over n is not absolutely convergent. However, so that's the easy part, I guess. However, didn't we just, I think it was a slight, the power of n was a little different, but didn't we just show that does converge? Isn't that the negative, the alternating harmonic series? That's the alternating harmonic series. It does converge, doesn't it? It doesn't absolutely converge, but it converges. That was, I think that we did that by the alternating series test. Well, so what does that mean when you have not absolutely convergent, but it does converge? Well, the way the book phrases it, that series is conditionally convergent. It's not absolutely convergent, but it is convergent. So if a series converges, but doesn't absolutely converge, it's said to be conditionally convergent. So if you see that term, that's what it means. It means it converges, but it doesn't absolutely converge. You can't do the absolute values and get it to be convergent. But it still does converge. Those things can be, that can be done. That's a good example. Okay, so let's take a look at this series. Negative 1 to the n plus 1 times the square root of n over n squared plus 3n plus 4. So this is the way they may act. So is that absolutely convergent? Conditionally convergent? Or divergent? Someone may ask that. Well, let's just try the absolute one first. Of course, that just knocks out the alternating. These are all positives, so yeah. So takes us into a series there without the alternating sign, so that opens up other tests, possibly. What test would you think?
Divergence.
Test for divergence? I think that this is going to go to 0. I guess that because the power on the top is less than the power on the bottom, so that usually that's okay. Usually that means your test for divergence won't. This limit is going to go to 0. if the power of the top is less than the power of the bottom, that's in the 1/2, that's in the second. You see what I'm saying?
Yeah.
So as long as the power of the top is less than the power of the bottom, that's usually not test for divergence. So what else did you guess? What else? Well, it's definitely not just a p-series or a geometric series. So that would leave comparison, limit comparison. And again, with the complicated look of it, I would probably say limit comparison test. So on the limit comparison test, remember that'll be the A sub n series. So for the limit comparison test, what do we do for the B sub n? Remember? Go with the largest power on top divided by the largest power on the denominator. See what that gets you? Well, that would be 1 over n to the, that's half power, that's 2 power, so would this be 3/2? You can either write it as n to the -3/2 or 1 over n to the +3/2, but I write it as this because, yeah, that's a p-series, isn't it? P equals 3/2, which is greater than 1. Convergent. So that was the series of the absolute values is convergent. What does that tell you? That's absolutely convergent.
We have to do the limit first.
Oh,
Know that?
yeah, sorry. Yeah, you do. There's more to it.
You got
I'm
to
just
do another
checking.
test inside of it.
I'm just checking it. Yeah, I still got, there's another part to it, which is the limit of the A sub n. What would be some thing? It's about to forget a whole part of that. And so that's the limit as n goes to infinity. A sub n, so this is A sub n right here. Divided by B sub n. I'm going to go with that. I think that'll work to my advantage. It probably, I mean, you get it work out either way. Well, of course, that means limit as n goes to infinity, square root of n over n squared plus 3n plus 4 times what? Reciprocal of that, n squared, and that's why I left it in that form, because if I do the reciprocal of that with that, square root of n's are going to cancel. It would still work out if you went with that, but pretty nice that way. So yeah, we've got the limit as n goes to infinity of n squared over n squared plus 3n plus 4. So divide top and bottom by n squared. To show here, what do we got? 1 over 1 plus 3 over n plus 4 over n squared, which is 1 over 1 plus 0 plus 0. Those two go to 0. That's 1. Now we can say, in the limit comparison test, as long as that's a finite number, greater than 0, we're good. So both of them then. So that tells me that limit's 1. Both of them do the same thing. If one of them is convergent, the other one is convergent. So I got one of them, B sub n is convergent, so the series of A sub n converges. I'm going to write that whole thing. Now, what does that mean, though, in the context of this problem? This converges. What does it mean about that? Well, the absolute value one of that converges. This is absolutely convergent. the series, -1, and that's kind of what's confusing about it. You get convergent here, but it means absolute convergence to the original one. Okay. So again, if, I don't have another one, but if you get to this point and says, say this was divergent, and so that turned out to be divergent, what do you do then? If this diverges? Well, that doesn't mean you quit. That means you don't do the absolute convergence. You just do that, which the test would be alternating series test for if it was something like that. Try your alternating series test just on the series. And if that doesn't work, then go from there. All right.